Lesson 3, Reduction Oxidation, or Redox for short. Redox is kind of a continuation of our single displacement reactions. So for example, the formation of iron 2 nitrate from iron and copper 2 nitrate. There's iron by itself. Again, one of the reactants, iron. Copper 2 nitrate, there's copper, there's nitrate. And we're going to form iron 2 nitrate. I guess we're going to do the oxidation states first. So copper 2 has a positive 2 charge, nitrate has a negative 1. So put our parentheses around the polyatomic nitrate, put the 2 after it, and there we go. Elements by themselves always have an oxidation state of 0. So iron over here by itself, 0. All right, they're going to form iron 2 nitrate. So there's our FeNO3. And copper by itself. Copper can't just go away. I know that they don't say copper is one of the products. But we know that copper is there. It's being replaced, single replacement, by iron. All right, our iron 2 has a positive 2 charge. Our nitrate has a negative 1. And now copper, being that it's the element by itself, has a 0 charge. A 0 oxidation state is what we call it. All right, let's go ahead and balance for charge. Iron 2 nitrate. Again, the nitrate has a negative 1. The iron has a positive 2. So we'll put parentheses around the nitrate. It's going to take 2 of our negatively 1 charged nitrates to cancel out the 1 positively 2 charged iron. Add our states of matter. Again, nothing new here. Iron is a metal. By himself, he's going to be a solid. Copper 2 nitrate. We find a rule on the back of our periodic table. Rule 1, don't have to read very far. Rule 1 states nitrates and acetates are going to be soluble. So soluble means they will dissolve. AQ. Iron nitrate, we don't have to go very far. Again, rule 1, nitrates are soluble, so aqueous. Copper by itself then, that's a metal. It's not mercury. It's going to be solid. All right. Before I go ahead and erase my oxidation states, we're going to take a look at how copper started off as a positive 2 charge and at the end of the reaction was at a 0 charge. That means he gained electrons. You can think about it. Electrons have negative charge. So from positive 2 to 0, that means you've acquired or gained negative electrons, 2 negative electrons. We call gaining of electrons being reduced or reduction. Thus, our copper 2 plus ion, because there's an ion over here, copper 2 plus ion was reduced. Iron, on the other hand, went from 0 to positive 2. Iron lost electrons. The electrons came off of the atom of iron, and that made our iron 2 ion. So we call this an loss of an electrons, which is called oxidation. So iron was oxidized. There's a nice little saying that helps out for this. It's called Leo the lion goes grr. If you remember, Leo is loss of electrons is oxidation, and grr as gain of electrons is reduction. That should help you decide, hey, whoever's gaining electrons, so gaining negative charges from positive 2 to 0, that's being reduced. Whoever's losing electrons is being oxidized, Leo. And from 0 to positive 2, that would be a loss of electrons. So Leo the lion goes grr. Here's your homework. And if you're staying with me for just a minute, I'm going to do the first one as an example with you. So again, 3 things we need to do. Identify what type of reaction we're working with, synthesis, decomposition, or single displacement. Again, that's important because then it helps us decide if we need to work with aqueous and other solubility rules. Second thing, write your balanced chemical equation with predicting products, include your states of matter, and finally, part C here, identify, if you need to, and you may not have to for all of them, identify what's being oxidized and what's being reduced. Got 8 problems. Go ahead and get started. If you need some help, here we go. Number 1, sodium hydroxide reacts with bromine. So we'll start with our sodium iodide, NaI, and bromine. Okay, sodium being an alkali metal will have a positive 1 charge. Iodide being a halogen will have a negative 1 charge. So no subscripts are needed. 1 to 1, they balance out. Bromine, element by himself, he's going to be 0. Let's go ahead and predict our products. Bromine by himself, he's a halogen. He's going to replace the other halogen, which is iodine. So we're going to end up with sodium, bromide, and iodine by himself. Let's go ahead and balance for charge again first. Sodium, nothing's happened there. It's still a positive 1. Bromine, again being a halogen, is going to be negative 1. So no need for any subscripts here. 1 and 1 going to cancel out. Iodine is now by himself, so he is our 0. Okay, we don't need any subscripts on the compounds. How about the individual elements? Is bromine a diatomic? Yes, he is. Is iodine a diatomic? Yes, he is. All right. There are our correct subscripts. Now let's go ahead and balance for overall numbers with coefficients. I've got 2 bromine on the left. I need 2 on the right. So I'll put a coefficient 2 in front of sodium bromide. That gives me 2 sodiums now, so I'll put a 2 over here as well. Coefficient 2. That does 2 things. It helps my sodium, and it also helps balance my iodine. Wonderful. Now we're balanced. Let's now put in our proper states of matter. Sodium iodide. We need to find a rule for sodium iodide. Don't have to look too far. Rule number 2. This is going to be aqueous, AQ. For bromine, that's one of our 2 liquids. So put in a liquid here. Sodium bromide, again, we don't have to go very far. It's still rule number 2. So sodium bromide will be aqueous. And then iodine is solid. It's got a lot of electrons. Leads to a lot of LDFs. Even though it's a nonpolar bond, he's going to be a solid compound. All right. Finally, we need to determine who's being oxidized and who's being reduced. Part C here. Well, sodium went from positive 1 to positive 1. Sodium did nothing. He was neither oxidized nor reduced. Let's take a look at iodine. Iodine went from negative 1 to 0. So he gained positive charges, or in other words, he lost electrons. Keep in mind, electrons are negatively charged. So if you're going positive, that means you're losing electrons. Losing electrons, Leo the lion, Leo, loss of electrons is oxidized. So we can say I, negative 1, it's iodine, the ion, over here he's an ion, is oxidized. So iodine starts off as negative 1, he is oxidized. Well, that only leaves bromine left. Bromine starts off as 0. He ends as -1. He gained negative charges, which means he gained electrons. So bromine. Now, again, I don't put a charge on him. He's Br2. I put a charge on iodine, -1, because he has a charge. But over here, bromine, Br2, does not have a charge. So no reason to write one. Bromine is reduced. Which again means that he gained electrons.